So again, if the order doesn't matter and we're choosing a select amount from a certain group of things, if the order does not matter at all, then we would use a combination. But what if the order does matter? If the order does matter, then what we would use would be a permutation. Now, we've talked about permutations already. That's what the n factorial was. If I wanted to arrange 6 objects, I would do 6 factorial, and that would tell me how many. But here's the difference of what this formula represents. This is the permutation of n objects taken r at a time. So let's say I said I have 6 mugs, I don't know, coffee mugs. I have 6 different coffee mugs, and I have 2 friends over. And so I want to not only choose 2 of the coffee mugs, but I want to decide which one to give to each person. So not only am I choosing 2, but I'm also choosing the order in which I'm going to pass out the 2 coffee mugs. It's kind of a bad example, but permutation means that you're going to choose from the group and then take that group that you chose and put them in order. So what's different about this one, instead of just choosing and instead of just arranging like we did yesterday, we are doing both. We are choosing and arranging. And that makes this one a pretty important thing to have. Again, here's this formula. You'll notice the notation is very similar. Little subscript n, normal size, capital P, subscript, little r. Here's the formula for how it's calculated. That button is also in your calculator with all the other probability functions. So you can just go through and do it that way. But just understand how to work this factorial formula. But that's how you would figure that out. The hardest thing about these 2 sections is deciding, are you supposed to be using a combination or are you supposed to be using a permutation? And that's what we're going to kind of focus on today. So here are 2 different examples to kind of really illustrate to you the difference between the combination and the permutation. So here's a scenario. Your class is choosing representatives for student government, and there are 27 students in your class. So the first question is, in how many ways could you choose a president, a vice president, and a secretary? The second question is, in how many ways could you choose just 3 class representatives? The difference between these 2 questions is that in one of them, you're not only choosing 3 people, but you're also choosing what order to put them in. In the other one, you're not. A is the one where order matters because I have to choose 3 people, and then I have to decide which one's the president, which one's the vice president, and which one's the secretary. If I have 3 people and I want to arrange them into 3 slots, there's actually 6 ways that I could do that. So we have to take that into account. And so for this first one, this would be a permutation. We have 27, whoops, sorry about that. We have 27 people in our class, and we're going to choose and arrange 3 people into the different offices. And so I get out my trusty calculator, and I get 27p3, 17,550 possibilities. Isn't it kind of ridiculous to think that out of only 27 students, you get over 17,000 possible combinations of groups of 3 people if the order of them matters? Let's compare that to if the order does not matter. The other alternative here is that we just choose 3 people. There's no different office that we're putting them in. We're just going to choose 3. Do you think there would be more or less ways to do that? Well, let's see. This case would be a combination because order does not matter. So in this one, we would say 27, choose 3. And if I do that, 27, choose, oops, I just did a permutation again. Hold on. 27, choose 3. I get 2,925, which is still a lot of ways, but do you see it is significantly less than the permutation. The permutation adds more possibilities. Not only are you going to pick 3 markers out of the bag, but then you're going to put those 3 markers into an order. So there's an added step of arranging on top of all of these. Here's another example. Let's see if we can decide which one we would use. You're taking a trip by airplane, like I am probably right now as you read this, and you want to take some magazines with you on the flight. You have 12 different magazines and you want to pack 5. How many ways can you choose the magazines? If you're just going to throw them in your bag and take them with you, does it matter what order they're in? And the answer is no. It doesn't matter what order you pick them in. If you were trying to decide you're going to choose 5 and then decide what order to read them in, then there would be more possibilities. But this is only choosing, and that would be a combination. So we would say 12, choose 5, and that would be 792 possible combinations of 5 magazines out of 12. Okay? Now, just to summarize here, and this is really the big idea. I mean, these are 3 things that you must have memorized. It's not going to be enough to just understand it, when we do just these kinds of problems or just these kinds of problems. They will always, from now on, come to you all mixed up. So you have to know the difference. The main thing is if you are just arranging, like you have a group and you're going to take the whole group and put it in order. That's a permutation, but that's just going to be a factorial problem. Take the number of things you have, do that factorial, and that'll give you your total. Okay? If you are just choosing things, order is not important. That's when you do your combination formula. And if you're doing both choosing from a group and arranging the things you chose, that's when you get a permutation. Okay? Now, your assignment is a worksheet that I have posted on Blackboard for you. It's a little bit of a mix of the stuff we talked about yesterday and the stuff we talked about today. Make sure you read the directions carefully because there's some of them where you don't have to actually solve the question. It's not asking for an answer, it's just asking for information. So make sure you read so you don't do more work than you have to. This will be due on Monday when I come back, so however much you get done is completely up to you. Okay? Have a great weekend, guys. I'll see you later.